Okay, so we're going to talk about differential equations again. We're going to use separation of variables, but we're doing it with particular solutions. So what we're going to do is we're going to take what they've given us. We're going to solve for y, and then we're going to figure out what the particular solution would be. Then once we've gotten the particular solution, to get the next problem, they have some actual x's and y values that they want us to plug in to figure out a numerical value for y or x. So, like what we talked about the other day, we're going to separate this. So we're going to have dy equals, and I'm going to move this dx over here. So 2x dx, we're going to integrate both sides. The integral of dy is y. And then this is going to become 2x squared over 2 plus c. So we got 2's canceling. So we have x squared plus c. So they've given us this condition right here. So when x is 1, y is 7. So we're going to say 7 equals 1 squared plus c, and then we can solve for c. So when I move this 1 over, I'm going to get that c is 6. So what I can do here is I'm going to actually replace c with 6. So my particular solution is x squared plus 6. And then to advance, they want us to find y when x is 2. So if I plug 2 in, 6 plus 4 is 10. So what we're going to look for is up here where it says answer. Somewhere in the circuit, we should have one that says 10. And that's going to be on the second page here. So this is going to end up being number 2. And then we'll do the same thing. So we're going to take this, we're going to separate it. So I actually want y to end up over here, dx to end up over here, and we can think of it as multiplying dx over and multiplying y over, even though, like we talked about last time, that's not really what's happening. But that's kind of the easy math way to think of it, even though it's not exactly mathematically correct. So y dy equals x dx. So we're going to integrate. This is going to become 1/2 y squared, 1/2 x squared plus c. Now remember, this would actually be plus c over here, but we end up moving the c over and combining the two c's, so it's easiest just to list the one c there. Then we're going to solve for y. So if I multiply everything by 2, when I multiply this by 2, it's going to cancel. So I'm going to get x squared plus c is a constant. When I multiply that constant by 2, it's just a bigger constant. So it's still going to be c in that case. Then we're going to solve for y. So we're going to square root both sides. So plus or minus the square root of x squared plus c. Then we have this condition here that we need to have y be 8 when x is -1. Now when I plug 8 in here, I'm going to end up needing to square root both sides to get rid of that square root there. So what I actually ended up doing was I plugged it into this. So I said 8 squared is equal to negative 1 squared plus c. Subtract 1, c is 63. So over here, particular solution, x squared plus 63. Then it wants us to find y when x is 1. So y equals plus or minus the square root of 1 squared plus 63. So that's going to be the square root of 64. So plus or minus 8. So if we go to this next page, at the top here, we have an answer of 8. So this is going to be number 3. And we're going to keep advancing through this. So we have dy dt equals negative 2t over y. And so I want to move y over, so that's like multiplying both sides by y. Get my dt over here, so negative 2t dt. Integrate both sides. The integral of y is going to be 1/2 y squared. And when I integrate this, I'm going to get negative 2t squared over 2 plus c. Twos are going to cancel. I want to get rid of this 1/2, so multiply everything by 2. And then I'm going to square root both sides to get rid of the y squared. Alright, so then they told us y is negative 6 when t is 0. So negative 6, and I used this. Negative 6 squared equals negative 2 times 0 squared plus c. So that's 36. And then we're going to have 0 plus c, so c must be 36. Alright, so then it says find t when y is negative 3 square root of 2. Okay, so what I did here is I square rooted both sides. Not square rooted, squared both sides. And so when I square this, I'm doing negative 3 square root of 2 times negative 3 square root of 2. That's going to end up being like 9 times 2. So I'm going to get 18 equals. When I square this, I'm just going to get what's left there. And whether it's positive or negative, it doesn't matter. When I square it, it becomes positive. Then I'm going to solve for t. So we have negative 18 equals negative 2t squared. Divide by negative 2. So we're going to get 9 equals t squared. That's going to be plus or minus the square root of 3 when I square root both sides. Okay, so plus or minus 3. So I want to look for where I have 3. And that's going to go back to the very first page. So this will end up being number 4. And you will continue that pattern. So I will tell you guys the very last page here, okay, just to kind of help you out with the way this is going to go. Okay, so not the last page, second to last page. Okay, so this one right here, 1/5, this is going to end up being number 8 for you. And you do not have to do this problem. And that should be where you end.